So here they ask us to use log differentiation to differentiate this function. I think it's very important that you realize why you are using this. It's because you have a variable to a variable. So this we are going to need to use log differentiation on. All right, so the first step with log differentiation is that we take the natural log of both sides and we use our properties to try to simplify. And when we say use our properties, we are using the property that one multiplication becomes addition of two logs, one division becomes subtraction of two logs, numerator minus denominator, and that the powers can be brought down as coefficients. Okay, so those are the properties that we would use when trying to take the natural log and simplify. So for this question, I would start with this, and I would say this is natural log of y equals natural log of x square root of x. And you're thinking about the properties on the right-hand side. So here inside of this argument, I do not have multiplication or division. I just have a power. So that power can be brought down in front as a coefficient by log properties. So this is not taking the derivative. This is using a log property to say that the power can be brought in front as a coefficient. So you get square root x, natural log x equals natural log y. All right, so the hope is that now you have something you can actually differentiate. So the second step is to take the derivative. Now, the derivative of natural log will be the argument y, and then the derivative of the argument y prime. Now, over here, when I take the derivative of square root x natural log x, that is square root x times natural log x. So we will have to use our product rule with the first function as square root x, second function as natural log x. So the first function's derivative, I will rewrite this as x to the 1/2 and then use our power rule. So bring down the 1/2, subtract 1. And then second function's derivative is 1 over x. So I'm going to plug that into my product rule here. So I'll have natural log x times 1/2 x to the negative 1/2. And please notice here I am not putting parentheses, and the reason why I can do that is because this is one term, one term, one term, one term. So the parentheses are overkill here if I were to put them in as parentheses. Then we have plus our second, which is x to the 1/2 times 1 over x. Now, hopefully you're looking at this x to the 1/2 over x and saying, okay, I can just subtract those exponents. So when I subtract the exponent 1/2 minus 1, I'm going to, of course, get negative 1/2. So that will give us x to the negative 1/2 as the second term. And then for the first term, I personally would move the 1/2 x to the negative 1/2 up to the front. Natural log x equals y prime over y. Now, we're very much accustomed to factoring out the GCF. So if it does kind of dawn on you or you think about, let me factor out the GCF, you could certainly do that. So you could bring out the GCF over here of negative 1/2, and that would leave you with natural log. So if I take this negative 1/2 out, this x to the negative 1/2 out, I would have natural log x over 2 plus, and then remember this x to the negative 1/2 is being divided by x to the negative 1/2. So we have plus 1. Now, it's very tempting to be like, okay, I'm done. But you're not done because you have this whole mess about y prime over y. So the third step is that what we do is we multiply by y to get y prime by itself and substitute the definition that we had of y. So what I would do is I would take this whole equation on the left-hand side and multiply by y. That would cross out these y's, so I'm just left with y prime. And then on the right-hand side, I would multiply by y. But I'm not going to keep it in terms of y because y is equal to x square root of x. So I plug that in for y. So here's what it's going to look like. I'm going to have y prime is equal to, I'm going to substitute in that y is defined as x to the square root of x. So this will become x to the square root of x to the negative 1/2, and then parenthesis natural log x over 2 plus 1. Okay, now if you really want it to be fancy here, and I do want you to kind of think about this, is that you have a base x here, a base x here, and they are being multiplied. So you could add those exponents, so to speak. So you could combine this together to write it as x square root x minus 1/2 with just one base, and then natural log x over 2 plus 1. So either of these would be fine, but the second one is the more simplified version.